Welcome. Let us take a moment to settle in, to quiet the world around us, and to let our minds drift away from the concerns of the present day. We are about to embark on a long and peaceful journey, a slow exploration of a world that existed long before the first human voice ever echoed in a valley, a world ruled by a dynasty of creatures so magnificent and so strange that they continue to hold a powerful grip on our collective imagination. This is the story of the dinosaurs, a story written in stone and in silence, a story that we are, piece by piece, learning to read. To truly understand this lost world, we must first understand what precisely a dinosaur was. The word itself conjures images of immense scaly beasts, of towering giants and fearsome predators, but the scientific definition is a more specific, and in many ways, a more fascinating one. Dinosaurs were not just any large prehistoric reptile. They were a distinct and unique group of animals, defined by a series of key anatomical features that set them apart from all their contemporaries, and were the very secret to their incredible, long-lasting success. The most important of these features was in their posture. For hundreds of millions of years, reptiles had moved with a sprawling gait, their legs splayed out to the sides of their bodies, like a modern lizard or crocodile. This is a stable, but not a particularly efficient, way to move. Dinosaurs, however, evolved a revolutionary new stance. Their legs were positioned directly and vertically beneath their bodies, much like the pillars of a great temple. This upright, or erect, posture was a masterpiece of biomechanical engineering. It allowed them to support a much greater body weight with far less muscular effort. It allowed them to breathe more efficiently as they moved, and it gave them the potential for a far greater degree of stamina and agility than their sprawling cousins. This unique posture was made possible by a profound change in the structure of their hip. All dinosaurs share a specific feature in their pelvic girdle. The hip socket, or acetabulum, is a complete, open hole. This allowed the head of the femur, or thigh bone, to fit snugly and vertically into the hip, creating the strong, pillar-like leg arrangement that is their defining characteristic. And from this basic, shared hip structure, the dinosaurs diverged into two great and magnificent lineages, a division that forms the very foundation of their classification. The first of these groups was the Saurischia, the lizard-hipped dinosaurs. In these creatures, the pubis bone, one of the three main bones of the pelvis, pointed forwards, in arrangement similar to that of a modern lizard. This great lineage included two of the most famous kinds of dinosaur, the two-legged, carnivorous theropods, like the mighty Tyrannosaurus rex, and the colossal, four-legged, long-necked, plant-eating sauropods, like the gentle giant, Brachiosaurus. The second great lineage was the Ornithischia, the bird-hipped dinosaurs. In these creatures, the pubis bone had rotated backwards to lie parallel with the ischium bone, another of the pelvic bones. This created a hip structure that is, superficially, very similar to that of a modern bird. This lineage was composed entirely of herbivores, and it included a spectacular diversity of forms, from the great horned ceratopsians, like Triceratops, to the plate-backed stegosaurs, and the heavily armored ankylosaurs. Interestingly, and in a wonderful twist of evolutionary history, it was not the bird-hipped dinosaurs that gave rise to birds. It was the lizard-hipped theropods that would eventually evolve into the birds we know today, a poignant reminder that the paths of evolution are often complex and surprising. Beyond their unique hips and posture, dinosaurs also shared other defining features. They all possessed a distinctive opening in their skull, a hole in the bone, situated between the eye socket and the nostril, known as the antorbital fenestra. This feature, which is not found in other great reptile groups, likely served to lighten the skull without sacrificing strength, and may have housed a complex system of air sacs connected to their respiratory system. And it is important to remember what was not a dinosaur. The great, flying reptiles of the Mesozoic, the pterosaurs, were their close cousins, but they were a separate lineage, with a different anatomy and a different way of life. And the magnificent and often terrifying reptiles that ruled the Mesozoic seas, the dolphin-like ichthyosaurs and the long-necked plesiosaurs, were also from a completely different and more distant branch of the reptilian family tree. The term dinosaur refers specifically and exclusively to that great and diverse dynasty of terrestrial, upright walking reptiles that were the undisputed masters of the land for an almost incomprehensibly long period of time. The very word dinosaur has a fascinating story. For centuries, people in different parts of the world had been unearthing strange, colossal bones, interpreting them through the lens of their own myths and legends as the remains of giants, of dragons, or of great beasts from a forgotten age. But it was not until the early 19th century that these remains began to be studied with a scientific eye. In the 1820s, an English physician and amateur naturalist named Gideon Mantell, with the help of his wife Mary Ann, discovered a collection of strange, fossilized teeth in a quarry in Sussex. They resembled the teeth of a modern iguana, but they were immense. Mantell named the creature that they belonged to iguana. Around the same time, another English scholar, William Buckland, described a massive jawbone from Oxfordshire, which he named Megalosaurus, the great lizard. It was the great British anatomist, Sir Richard Owen, who in 1842 recognized that these creatures, along with a third, armored reptile called Hylaeosaurus, were not just giant lizards. They were something entirely new, a distinct and vanished group of reptiles that shared a unique set of anatomical features. Most importantly, their upright, pillar-like legs. To describe this new group, he coined a new and unforgettable name. He combined two ancient Greek words, dienos, meaning terrible or fearfully great, and sauros, meaning lizard, and so the world was introduced to the Dinosauria, the terrible lizards. The name was a powerful one, evoking the immense size and awe-inspiring nature of these creatures, and it has endured to this day as a perfect and iconic label for the lost world that they represent. The dawn of the dinosaurs occurred during the Triassic period, a time that began around 252 million years ago. The world they were born into was a harsh and challenging one. It was a world recovering from the most devastating mass extinction in its history, the Great Dying, which had wiped the slate of life almost completely clean. The continents were fused together into a single, colossal supercontinent called Pangaea. The climate was, for the most part, hot and arid, with vast deserts dominating the continental interior. The first dinosaurs, which appeared around 230 million years ago in the part of Pangaea that would one day become South America, were not the titans of later ages. They were small, agile, and lightly built creatures, overshadowed by the larger and more dominant crocodile-lion archosaurs that were the true rulers of the Triassic world. Creatures like Eoraptor and Herrerasaurus were nimble, bipedal pioneers, just one of many evolutionary experiments in this recovering world. Their future dominance was far from guaranteed, but they possessed the key adaptations, the upright stance, and the efficient gait that would, over the next 30 million years, allow them to survive, to adapt, and to be perfectly poised to inherit the Earth when the next great extinction event cleared the world of their rivals at the end of the Triassic. These humble beginnings are a crucial part of their story. They were not born as giants, they were born as survivors, and it was their resilience that would be the foundation of their long and magnificent reign. We now journey forward from the very dawn of the dinosaur lineage. We have met the first, humble pioneers, the small, agile, and lightly built creatures like Eoraptor and Herrerasaurus, who took their first steps in a world that was not their own. The Triassic period, the first chapter of the Mesozoic era, was not yet the age of dinosaurs. It was an age of recovery, an age of bizarre experiments, and an age ruled by other, older, and for a time, far more powerful dynasties of reptiles. To truly understand the incredible story of the dinosaurs' rise to dominance, we must first immerse ourselves in this strange and fiercely competitive world they were born into, a world where their survival, let alone their future supremacy, was far from guaranteed. Let us first paint a picture of this Triassic world. The great supercontinent of Pangaea, a single colossal landmass, dictated the global climate. Its immense interior, far from the moderating influence of the oceans, was a vast and punishing desert, a sea of red sand and rock that baked under a relentless sun. Life was a difficult proposition here, confined to the hardy plants and creatures that could endure the extreme heat and prolonged droughts. But along the coastlines of the great global Panthalassa Ocean and the newly forming Tethys Sea, and within the great river valleys that carved their way through the arid interior, life was a different story. These were ribbons of green in a world of red, lush, temperate, and monsoonal environments, teeming with a strange and diverse cast of survivors from the great Permian extinction. The forests were not the familiar woodlands of our time, but alien groves of hardy drought-resistant conifers, palm-like cycads, elegant ginkgos, and the ancient, resilient seed ferns like dicrodium. It was in these green corridors of life that the great drama of the Triassic unfolded. And for most of this long, 50-million-year period, the leading actors were not the dinosaurs, but their close relatives, the other archosaurs, particularly the formidable Pseudotia, the crocodile-line archosaurs. These were the true rulers of the Triassic world, and they diversified into an incredible and often terrifying array of forms. The role of the apex terrestrial predator, the creature at the very top of the food chain, was held by the mighty Rauisuchians, a creature like Postosuchians, which stalked the landscapes of what is now North America, was a 9-meter-long engine of destruction. It was a powerfully built quadruped, but it could likely rear up and run on its 2 hind legs for short bursts of speed. Its massive skull, filled with long, blade-like serrated teeth, was a weapon capable of bringing down the largest herbivores of its time. For millions of years, creatures like Postosuchians were the undisputed kings. The great land sharks of the Triassic and the small early dinosaurs would have lived in a state of constant mortal fear of them. The role of the large, armored herbivore was also not held by a dinosaur. It was perfected by another group of pseudocians, the Dinosaurs. A creature like Desmatosuchus was a walking fortress, a low-slung, powerfully built animal covered from snout to tail in a dense, interlocking mosaic of thick, bony plates or scutes. But its most spectacular feature was the pair of immense, curved, sharp horns that projected outwards from its shoulders, a formidable defense against the great Rauisuchian predators. They were the living tanks of the Triassic, peaceful herbivores that had evolved one of the most effective suits of armor in the history of life. And the great rivers, lakes, and swamps of the Triassic were patrolled by yet another Pseudocian dynasty, the Phytosaurs. In a stunning example of convergent evolution, these creatures had evolved a body plan and a lifestyle that was almost identical to that of our modern crocodiles. They were semi-aquatic ambush predators with long, powerful bodies, armored backs, and immensely long snouts filled with conical, fish-catching teeth. The only obvious external difference was that their nostrils were located high up on their heads, just in front of their eyes, rather than at the tip of the snout. They were the undisputed rulers of the Triassic waterways, a testament to the enduring success of the crocodile-like body plan. Alongside these ruling archosaurs, other strange groups of reptiles also thrived. There were the rhynchosaurs, bizarre, pig-sized, beaked herbivores whose strange teeth were fused to their jawbones, forming a powerful chopping plate for slicing through tough plant matter. And our own distant kin, the synapsids, the survivors of the Permian extinction, were also present. The cynodonts, like the large, wolf-like Cynognathus, were still formidable predators in their own right, but they were being steadily outcompeted by the more efficient archosaurs, and so they began to adapt to a life in the shadows, becoming smaller, more nocturnal, and ever more mammal-like, biding their time, waiting for an opportunity that would not come for another 150 million years. It was into this crowded, dangerous, and fiercely competitive world that the first dinosaurs took their first tentative steps. We see them emerge in the fossil record of the late Triassic, in the temperate, forested landscapes of southern Pangaea. These were not giants. They were small, nimble, and lightly built creatures, but they possessed the key adaptations that would be the secret to their long-term success. Their upright, pillar-like legs gave them a greater stamina and efficiency of movement. Their bird-like lungs allowed them to process oxygen more effectively, and their fast growth rates allowed them to reach maturity more quickly than many of their rivals. The Saurischean, or lizard-hipped, pioneers, like Eoraptor and Heretosaurus, were the blueprints for the great predatory and long-necked lineages to come. And at the same time, the first of the great herbivorous lineages were also beginning to stir. The sauropodomorphs, the ancestors of the long-necked giants, first appeared as small, bipedal herbivores, but they quickly began to experiment with larger sizes. A creature like Plateosaurus, from the late Triassic of Europe, was one of the first truly large herbivorous dinosaurs, reaching up to 10 meters in length. It could walk on its two powerful hind legs, but also on all fours. It had a long neck for browsing on high vegetation, and a small head with simple, leaf-shaped teeth. Great herds of Plateosaurus likely roamed the Triassic plains, the first sign of the gigantism that would come to define their lineage. And the Ornithischians, the bird-hipped dinosaurs, also made their first humble appearance. A creature like Patagonia, from the same fossil beds as Heretosaurus, was a small, bipedal plant eater, one of the very first of the great lineage that would one day produce the stegosaurs, the ankylosaurs, and the ceratopsians. But for now, they were rare, small, and insignificant players in a much larger drama. For millions of years, this was the state of the world, a complex and dynamic ecosystem ruled by the pseudoceans, with the dinosaurs as a small but persistent and diversifying minority. But the very geological forces that had defined the Triassic world were about to bring it to a sudden and violent end. The great supercontinent of Pangaea, which had been a single landmass for so long, was beginning to tear itself apart under the strain of the Earth's inner heat. A great rift began to form between the continents, a wound that would one day become the Atlantic Ocean. And as this rift opened, it triggered the second great flood basalt event of the Mesozoic. This was the eruption of the Central Atlantic Magmatic Province, or CAMP, over a period of some 600,000 years. Colossal, intermittent volcanic eruptions poured out an immense volume of lava and a catastrophic amount of climate-altering gases into the atmosphere. The world was plunged into a new climatic crisis, a brief, but intense, volcanic winter, caused by the sun-blocking effects of sulfur aerosols, was followed by a prolonged and extreme period of runaway greenhouse warming, caused by the massive injection of carbon dioxide. The oceans became acidic, and the world's ecosystems, which had so patiently rebuilt themselves over the preceding 50 million years, were once again pushed to the breaking point. This was the Triassic-Jurassic extinction event, and like the great extinctions before it, it was a selective filter. The victims were numerous and specific. The great labyrinthodont amphibians vanished forever. The strange rhynchosaurs disappeared. The conodonts in the seas went extinct. And most consequentially of all, the great ruling dynasty of the Pseudocians, the Rauisuchians, the Atosaurs, and the Phytosaurs were almost completely wiped out. The dinosaurs' chief ecological competitors were gone. And the dinosaurs themselves, along with their close cousins, the pterosaurs, and the crocodilian ancestors, survived. Why? Their efficient, bird-like respiratory system may have allowed them to cope better with the low oxygen, high carbon dioxide atmosphere of the time, and their potentially higher metabolisms and insulating protofeathers may have helped them to survive the initial, shocking cold snap of the volcanic winter. Whatever the precise reasons, they had passed through the fire, and so, we arrive at the dawn of the Jurassic period, 201 million years ago. The world is, once again, a world of opportunity. The Great Extinction has acted as a final, decisive clearing of the board, and the dinosaurs, the resilient survivors of the Triassic, now stand as the unopposed heirs to an empty planet. The world was now theirs for the taking, and in the new, warmer, wetter, and greener world of the Jurassic, they would rise from the ashes of the Triassic, and they would grow into the undisputed, colossal, and magnificent giants that would rule the Earth for the next 135 million years. The world that dawned at the beginning of the Jurassic period, some 201 million years ago, was a world in the process of a profound and fundamental transformation. The great supercontinent of Pangaea, which had defined the planet's geography for nearly 100 million years, was dying. The immense volcanic eruptions that had triggered the great extinction were a symptom of this death, the fiery birth pangs of a new world. The continental crust was stretching, thinning, and finally breaking apart. A great rift, which would one day widen to become the Atlantic Ocean, was now a long and growing scar that snaked through the heart of the landmass, and into this rift, the sea was beginning to flood. This slow, inexorable process of continental drift had a powerful and transformative effect on the global climate. The vast, arid deserts that had dominated the interior of Pangaea, far from the moderating influence of the oceans, began to shrink. With new coastlines and new inland seas forming, more moisture was carried into the atmosphere. The world became a warmer, wetter, and more stable place. This new global greenhouse climate, combined with the high levels of atmospheric carbon dioxide left over from the great volcanic eruptions, created a paradise for plant life. The landscape of the Jurassic was a world of green, on a scale that had not been seen for 50 million years. The hardy, scrubby plants of the Triassic were replaced by vast, lush, and sprawling forests. These were not the flowering forests of our own time, but a more ancient and primal woodland. The canopy was dominated by immense conifers, trees like the majestic Araucaria and the ancestors of our modern redwoods, their towering trunks rising like the pillars of a great, natural cathedral. The middle layer of the forest was filled with groves of palm-like cycads, their stiff, leathery fronds forming dense thickets, and elegant, fan-leaved ginkgo trees, and the forest floor, and the great, open floodplains between the forests, were not covered in grass, which had not yet evolved, but in immense, unbroken prairies of ferns, horsetails, and club mosses. This incredible planet-wide abundance of vegetation, this planetary buffet of immense scale, was the essential fuel that would power the great evolutionary explosion of the dinosaurs. And it was in this new green and empty world that the dinosaurs, the unopposed inheritors of the planet, began their true reign. Freed from the competition of the great pseudocean reptiles that had dominated the Triassic, they underwent an explosive evolutionary radiation, diversifying with incredible speed and seizing every major terrestrial ecological niche. And the most spectacular and defining feature of this new age was their embrace of gigantism. This was the golden age of the sauropods, these long-necked, plant-eating titans, which had their humble origins in the late Triassic, now achieved sizes that test the very limits of biological possibility. To be so colossal presented a host of profound engineering challenges. An animal's weight increases with the cube of its dimensions, while the strength of its bones increases only with the square of their cross-section. This meant that a truly gigantic animal risked collapsing under its own immense mass. It also needed to consume a phenomenal quantity of food, pump blood up a neck the length of a building, and avoid overheating its vast body. The sauropods evolved a suite of brilliant and interconnected solutions to these problems. Their very skeleton was a masterpiece of lightweight engineering. Their vertebrae, the bones that made up their spine and neck, were not solid bone. They were hollowed out by a series of intricate air sacs known as pleurocoels. These hollows were extensions of their highly advanced, bird-like respiratory system. This made their skeletons incredibly strong, but also remarkably lightweight for their size, a solution that evolution would later use again in the flying pterosaurs and modern birds. This respiratory system, with its one-way flow of air, was also super efficient, providing their massive bodies with the constant supply of oxygen needed to fuel their metabolism. Their feeding strategy was a model of energy conservation. A sauropod's head was tiny in comparison to its body, and its teeth were simple, peg-like or spoon-shaped structures. They did not waste precious time or energy chewing. Instead, they used their teeth like garden rakes, stripping enormous quantities of leaves, ferns, and cycads from the vegetation and swallowing it all whole. The real work of digestion took place in their colossal, vat-like gut, a giant fermentation chamber, where microbes would work to break down the tough plant cellulose over a long period, possibly aided by swallowed stones called gastroliths that would help to grind the food. Their most iconic feature, the incredibly long neck, acted as a giant feeding boom. It allowed them to stand in one spot and browse a huge arc of vegetation, from low-lying ferns to the tops of the conifer trees, without having to move their gargantuan bodies, saving an immense amount of energy. The Jurassic landscape was populated by a majestic parade of these gentle giants. There was Brachiosaurus, one of the most famous of all. Its body was built like a giraffe, with front legs that were significantly longer than its hind legs. This gave it a steeply inclined back, holding its long neck at a high upward angle. A living crane, perfectly adapted for browsing on the foliage of the very tallest trees, far beyond the reach of any other herbivore. Its contemporary, Diplodocus, had a completely different but equally successful body plan. Its back was held horizontally, and its neck was incredibly long, but also held horizontally, parallel to the ground. It was a low browser, using its neck to sweep from side to side across the vast fern prairies like a giant scythe, consuming huge swathes of vegetation. Its tail was even longer than its neck, an impossibly long whip-like structure that it may have used as a formidable defensive weapon against predators, or perhaps cracked like a bullwhip to create thunderous sounds for communication. Its close relative, Apatosaurus, often known by its more famous but junior synonym, Brontosaurus, was even more robust, a true powerlifter of the Jurassic, with a massively thick neck and a powerful, stocky build. While the sauropods dominated the landscape through sheer scale, another great herbivorous dynasty, the Ornithischians, was perfecting the art of defense. This was the age of the stegosaurs. The most famous of all, Stegosaurus, was a large, four-legged herbivore that roamed the same fern prairies as the great sauropods. Its back was adorned with a double row of large kite-shaped bony plates. These plates, once thought to be armor, were thin and riddled with blood vessels, and were most likely used for display, a vibrant, colorful billboard to attract mates and intimidate rivals. They may also have functioned as radiators, helping to regulate the animal's body temperature. For true defense, Stegosaurus was equipped with something far more effective. At the end of its powerful tail were four long, sharp, bony spikes. This weapon, the Thagomizer, could be swung with lethal force, and the fossilized evidence of a punctured Allosaurus vertebra proves that it was a weapon they used with deadly effect against the great predators of their time. And the great predator of the late Jurassic, the undisputed king of its ecosystem, was Allosaurus. This was a large and powerful theropod, a hunter of giants. Its massive skull was a lightweight but strong latticework of bone, and its jaws were filled with long, sharp, serrated teeth that were constantly being replaced. Its arms were powerful, and its three-fingered hands were armed with huge, hooked claws for grappling with prey. Allosaurus was the primary predator of the stegosaurs and the young or weak sauropods. It likely hunted with a combination of ambush and brute force, perhaps working in packs to harry the great herds, looking for an opportunity to isolate a vulnerable individual and bring it down with its devastating bite. It shared its world with other large carnivores, like the horn-nosed Ceratosaurus and the even larger and more robust Torvosaurus, ensuring that the lives of the great herbivores were ones of constant vigilance. This was the Jurassic world at its zenith, a stable, majestic ecosystem of titans, a world in a state of sublime and mighty equilibrium, a world in flux, said Phil. Our story now carries us across the boundary, from the Jurassic into the Cretaceous period, a vast stretch of time that began approximately 145 million years ago. This was an era of profound global change. The breakup of the ancient supercontinents, Laurasia and Gondwana, accelerated. The landmasses we know today were beginning to take on more familiar shapes, though their positions were still vastly different. As the continents pulled apart, a new and powerful geological force took hold, an increase in the rate of seafloor spreading at the mid-ocean ridges. This volcanic activity displaced enormous volumes of ocean water, causing sea levels to rise dramatically, reaching some of the highest points in our planet's history. Vast, shallow inland seas flooded the continents, dividing them into smaller, isolated landmasses. In North America, the Great Western Interior Seaway would eventually split the continent in two, from the Arctic all the way to the Gulf of Mexico. This fragmentation created a world of islands and archipelagos, each one becoming a separate crucible for evolution. The climate of this new world was a stable and extreme greenhouse. Temperatures were high across the globe, and with little to no ice at the poles, lush, subtropical forests likely extended all the way into the Arctic and Antarctic circles. And in this warm, wet, and stable world, a quiet but momentous revolution was taking place at the very foundation of the food chain. This was the rise of the angiosperms, the flowering plants, the botanical revolution. For over 100 million years, the world's landscapes had been dominated by the ancient lineages of gymnosperms, the conifers, the cycads, and the ferns. But these new flowering plants possessed a suite of competitive advantages. The flower. They evolved the flower, a sophisticated and often beautiful reproductive structure designed to do something revolutionary to entice animals into their service. By offering nectar as a reward, they co-opted a new and burgeoning group of insects into acting as dedicated couriers for their pollen, making their reproduction far more efficient than the wasteful, wind-based pollination of the conifers. This sparked a great coevolutionary dance, and the first true bees, butterflies, and moths appeared and diversified alongside their floral partners. The fruit. The angiosperms also invented the fruit, a protective and often nutritious vessel for their seeds, which again enticed animals into dispersing their offspring far and wide. Rapid growth, and they could grow and colonize disturbed land far more quickly than the slow-growing gymnosperms. Throughout the early and middle Cretaceous, these new, tough, and fast-growing plants began to take over the world's understory, creating new types of dense, scrubby habitats. This profound shift in the world's flora had a direct and dramatic impact on the great dinosaurian herbivores in the northern continents, the great Jurassic sauropods, and the plated stegosaurs, which were adapted to a world of open fern prairies and cycad groves, began a slow decline. Their world was changing beneath their feet, while the sauropod lineage would continue to thrive and produce new, even more colossal titans in the southern continents of Gondwana. In the north, a new dynasty of herbivores rose to prominence, one that was perfectly equipped to deal with the new, tougher vegetation. These were the ornithopods, a new order of herbivores. The quintessential herbivore of the early Cretaceous was Iguanodon. This was a large, powerful, and incredibly successful dinosaur. It was a versatile walker, capable of moving on all fours to browse on low-lying plants, or rearing up on its powerful hind legs to reach higher. Its mouth was a formidable cropping tool, with a sharp, toothless beak, and most importantly, the ability to chew its food with a complex grinding motion, an adaptation that gave it a huge advantage in processing the tough new angiosperms. For defense, it wielded a unique and iconic weapon, a conical sharp spike on each of its thumbs, a formidable dagger for fending off the great predators of its time. From these successful iguanodonts, an even more advanced group began to evolve the hadrosaurs, or duck-billed dinosaurs. They perfected the art of chewing, evolving incredibly complex dental batteries with hundreds of teeth packed into a single, ever-replacing grinding surface, making them the most efficient herbivores the world had yet seen. As the ornithopods rose, the stegosaurs faded into extinction, and their role as the armored herbivore was taken up by a new and far more impregnable dynasty, the ankylosaurs. These were the ultimate living fortresses. A creature like Sauropelta, from the early Cretaceous of North America, was a low, wide, and immensely heavy animal, its back and neck protected by a dense mosaic of bony plates and multiple rows of long, terrifying spikes that projected outwards. This was an animal that was almost impossible to attack from above. The famous Borealopelta fossil, a mummified nodosaur from Canada, was preserved in such exquisite detail that we can still see its reddish-brown pigmented skin and the keratin sheaths on its armor. A new breed of predator. With this changing of the guard among the herbivores, a new generation of predators evolved to hunt them. The allosaurs of the Jurassic were succeeded by a new and even more terrifying family of giant theropods, the Carcharodontosaurids, the shark-toothed lizards. These were the true tyrants of the mid-Cretaceous. On the island continent that was South America lived Giganotosaurus, a predator of almost unbelievable size, a hunter that may have been even longer and heavier than Tyrannosaurus rex, and it was the apex predator in a world still home to colossal 100-ton titanosaurs. In Africa, there was its cousin, Carcharodontosaurus, another giant with a massive skull filled with long, blade-like, serrated teeth, perfectly designed for slicing through flesh. And in North America, there was Acrocanthosaurus, a formidable giant with a distinctive high ridge of spines running along its back. While these giants reigned as apex predators through sheer size and power, another, very different, and perhaps even more fearsome group of hunters was evolving. These were the dromaeosaurs, the feathered raptors. A creature like Deinonychus from the mid-Cretaceous of North America was a revelation. Its discovery in the 1960s single-handedly overturned the old image of dinosaurs as slow, stupid, and lumbering brutes. Deinonychus was a sleek, fast, and agile predator with a large brain, forward-facing eyes for binocular vision, and a stiff, balancing tail. It was covered in a coat of complex, bird-like feathers, and on each foot, it wielded its signature weapon, a large sickle-shaped, retractable claw. Fossil evidence suggests they hunted in coordinated packs, a team of feathered assassins, capable of bringing down prey much larger than themselves. This was the new world of the Cretaceous, a world of profound change and diversification. The stage was now being set for the final and most spectacular act of the Age of Dinosaurs. A great oceanic extinction event around 94 million years ago would wipe out the mighty Carcharodontosaurs, clearing the path for a new family of predators, the Tyrannosaurs, to rise to the throne. The world was on the cusp of the late Cretaceous, an age that would produce the most famous and fantastic dinosaurs of them all, the final kingdom. Our journey now takes us into the final 15 million years of the Mesozoic era. The late Cretaceous was a world that in many ways would have looked surprisingly modern. The continents had drifted into a configuration that is almost recognizable to us. The Atlantic Ocean was widening, and the great island continent of Laramidia, which is now the western portion of North America, was a long, narrow landmass, bordered on the east by the warm, shallow waters of the western interior seaway. The climate was that of a hothouse, a warm, wet, and subtropical world, and the landscape was a lush tapestry of flowering plants. Great forests of magnolias, sycamores, and palms lined the banks of meandering rivers that flowed from the newly forming Rocky Mountains down to the coast. This was the stage, a vibrant and productive world, for the final and most spectacular act in the great drama of the dinosaurs. The great herds hadrosaurs, perfected. The dominant herbivores of this new world were the hadrosaurs, the duck-billed dinosaurs, who had now reached the apex of their evolution. They were the great herds of the late Cretaceous, the cattle of their age, and they existed in immense migratory herds that likely numbered in the thousands. Their success was founded upon their jaws, which contained the most sophisticated chewing apparatus of any reptile in history. Their batteries of hundreds of self-sharpening teeth were a perfect grinding mill for the tough, fibrous, and now abundant flowering plants. The most common of these was Edmontosaurus, a colossal animal that could reach lengths of 15 meters or 50 feet and lived in immense migratory herds. But even more spectacular were the crested hadrosaurs, the lambeosaurines. Their hollow head crests were some of the most bizarre and wonderful structures in the entire animal kingdom. A creature like Parasaurolophus, with its long, sweeping, trombone-like crest, was a living musical instrument. The crest was a network of hollow tubes connected to its nasal passages. By exhaling through this complex resonating chamber, it could have produced deep, resonant, trombone-like calls that would have echoed for miles across the Cretaceous landscape. These were the sounds of communication, used to keep the vast herds together, to warn of approaching danger, or to call for mates. Each species, from the helmet-crested Corythosaurus to the hatchet-crested Lambeosaurus, had its own uniquely shaped crest that would have produced its own unique call, a specific acoustic signature that allowed them to identify their own kind in a world filled with the calls of other giants. The Unbreakables, armored and horned, titans. While the hadrosaurs found safety in numbers, other herbivores relied on the perfection of personal defense. The ankylosaurs, the living tanks, reached their ultimate form in Ankylosaurus itself. This was a fortress of a creature, low, wide, and incredibly heavy. Its entire back, neck, and head were encased in a solid shield of thick, interlocking bony plates, and even its eyelids were armored. But its true weapon was its tail. The end of its tail was a massive, fused knob of solid bone, a colossal sledgehammer that it could swing with devastating force. The tail leading to this club was stiffened by interwoven tendons, turning it into a rigid, powerful handle. This was a weapon perfectly designed to be swung low to the ground, to shatter the ankle or leg of the only predator that dared to attack it. And vying for the title of the ultimate herbivore was the final great dynasty to emerge, the ceratopsians, the horned dinosaurs. The most famous and the largest of these was Triceratops. This was a magnificent animal, 9 meters long and weighing up to 12 tons. Its head was a masterpiece of both offense and defense. It had a powerful, parrot-like beak for slicing through tough cycads and palms. For defense against predators, it wielded 3 formidable horns, 2 long, sharp brow horns, and a shorter, robust horn on its nose. And sweeping back from its skull was its great, solid shield of bone, the frill. This frill protected its vulnerable neck, but it was also a giant billboard for display, likely flushed with bright colors to intimidate rivals and attract mates. It also served as a massive anchor for the incredibly powerful jaw muscles it needed to slice through the toughest vegetation. Triceratops was a formidable and successful animal, living in great herds, a walking bastion that even the greatest predator would have thought twice about attacking. The tyrant king ascends to hunt this incredible menagerie of advanced and well-defended herbivores. The theropod dinosaurs produced their ultimate creation. The lineage of carnivorous dinosaurs, which had begun with small, slender creatures in the Triassic, culminated in the late Cretaceous with the tyrant lizard king, Tyrannosaurus rex. It was one of the largest terrestrial carnivores of all time, an animal of immense power and surprising sophistication. Its most devastating feature was its head. The skull was over 1.5 meters long. But it was not just a block of bone. It was a complex and dynamic structure, with fused nasal bones for strength in biting, and kinetic joints that could absorb the shock of struggling prey. Its eyes were positioned forward, giving it excellent, overlapping binocular vision, and the depth perception of a hawk, a perfect tool for a hunter. And the olfactory bulbs in its brain were enormous, suggesting a sense of smell so acute it could likely track its prey, or a distant carcass, over many miles. But it was the jaws and teeth that made T-Rex the ultimate predator. Its teeth were not the blade-like slicers of the Carcharodontosaurs that came before it. They were thick, serrated, railroad spikes of bone and enamel, designed not just for cutting flesh, but for punching through armor and shattering bone. The muscles that powered these jaws were immense, giving it the most powerful bite force of any land animal that has ever lived, a bite capable of generating over 12,000 pounds of pressure. This was not a delicate slicer, but a bone-crushing pulverizer. Tyrannosaurus rex was the keystone predator of its environment, a hunter perfectly and terrifyingly evolved to take on the most dangerous and well-armed herbivores of all time, the hadrosaurs, the ankylosaurs, and the mighty Triceratops. This was the world in its final, glorious, and stable moment, a world of vast, communicating herds of duckbills, of powerful, horned ceratopsians, of impregnable, armored tanks, all living in a dynamic and balanced ecosystem, presided over by the most powerful predator the land had ever known. This was the pinnacle, the final, beautiful, and terrifying expression of the age of dinosaurs. This world, so successful, so complex, and so enduring, had no reason to believe its time was coming to an end. But as this world turned, peacefully, beneath a familiar, star-filled sky, a silent and indifferent object, a tiny speck of light from the deep, cold darkness of space, was growing ever brighter, an object on a collision course with destiny, an emissary from the cosmos, carrying with it a judgment of absolute and fiery annihilation. We now arrive at the threshold of the abyss. The world in its final, perfect moment of peace is a world unaware that its fate, sealed billions of years before in the chaotic formation of the solar system, is now arriving from the deep, cold darkness. The messenger approaches. It is a piece of the cosmos itself, a chondritic asteroid, born from the same primordial dust and gas that formed the Earth. For 4.5 billion years, it has been a silent traveler, its orbit occasionally nudged by the immense gravity of Jupiter, a lonely wanderer in the interplanetary void. Now its final, intersecting trajectory has been set. It is a mountain of rock and iron, 10 kilometers in diameter, and it is plunging towards the sunlit side of the planet at a speed of 20 kilometers per second, a velocity so extreme, it is almost beyond any terrestrial comparison. In the final minutes of its existence, it crosses the orbit of the moon. From the surface of the Earth below, in the regions of Laramidia and what would become Central America, it would first appear as a new, impossibly bright star, a pinpoint of light that does not twinkle, but grows with a steady, terrifying intensity. As it plunges into the thin, outer wisps of the Earth's atmosphere, its journey becomes a spectacle of pure, silent physics. The air in its path cannot be pushed aside. It is compressed into a shockwave, a cushion of gas, heated to a temperature of thousands of degrees, a plasma hotter than the surface of the sun. The asteroid is now encased in a blinding shell of incandescent plasma, a man-made star hurtling towards the ground. Its surface begins to ablate, layers of rock and iron peeling away in the unimaginable heat and friction, creating a brilliant, silent trail across the morning sky. For any dinosaur that happened to witness this silent, terrible dawn, it would have been a sight of profound and incomprehensible awe, a godlike fire in the heavens, the very last thing it would ever see. It strikes a shallow, tropical sea that we now know as the Gulf of Mexico, just off the coast of the Yucatan Peninsula. The location of this impact is a matter of the most terrible and fateful geological luck. The crust in this region is formed of thick layers of carbonate and sulfate rocks, limestone and gypsum. This chemical composition means that the impact will not only be physically devastating, but it will also unleash a chemical poison into the global environment, a fact that will seal the fate of the dinosaurs. The moment of impact is not a collision in any ordinary sense. It is an act of planetary annihilation. The asteroid and a vast portion of the Earth's crust beneath it do not shatter or break. They cease to exist as solids or liquids. In less than 2 seconds, the entire 10-kilometer mountain of rock and iron and 100 cubic kilometers of the Earth's crust are instantaneously vaporized. The kinetic energy of the impact, equivalent to the detonation of over 100 trillion tons of TNT, is converted into an explosive release of heat and pressure. A bubble of superheated rock vapor and plasma, many times hotter than the sun's core, expands outwards with unimaginable speed. This explosion carves a hole in the planet. The initial transient crater is a wound 30 kilometers deep and over 100 kilometers wide, the rock within it behaving not as a solid, but as a fluid under the immense pressure. The Earth's mantle itself is briefly exposed before the crust rebounds in a colossal upward surge, creating a central peak ring of mountains higher than the Himalayas, which then collapses outwards in a matter of minutes to form the final, vast and permanent scar of the Chicxulub crater. The consequences of this single violent moment now begin to propagate across the globe in a series of devastating, planet-altering waves. First, a seismic shockwave of a magnitude that may have exceeded 12 on the Richter scale ripples through the very fabric of the planet. The ground itself would have been seen to ripple like water. This mega-quake would have triggered catastrophic earthquakes on every fault line on the planet, and it is believed to have dramatically intensified the ongoing flood basalt eruptions on the opposite side of the world, in the Deccan Traps of India. adding yet more poison to the atmosphere. At the same time, the impact displaces the atmosphere above it, creating a hypersonic air blast, a wall of superheated pressure moving at thousands of kilometers per hour, flattening and incinerating everything in a radius of over 1,000 kilometers. The impact into the shallow sea displaces 1 trillion tons of water, generating a mega tsunami of a scale that is almost mythological. An initial complex wave, generated by the blast and the collapsing crater walls, may have been over a mile high. This wall of water, traveling at the speed of a jetliner, races across the Gulf of Mexico. It scours the coastlines of Laramidia and the Proto-Caribbean islands, surging for hundreds of miles inland, a great scouring wave that would entomb entire ecosystems in a thick layer of marine sediment. Fossil deposits far inland in what is now Texas and Florida bear the chaotic, jumbled signature of this immense and ancient wave. But the most devastating of the immediate effects was a truly global phenomenon. The impact had blasted trillions of tons of molten rock, vapor, and debris high out of the atmosphere and into space on ballistic trajectories. As this material, now condensed into a thick, superheated swarm of tiny glass beads, or tektites, began to rain back down into the atmosphere everywhere on Earth, the friction of their passage began to heat the thin, upper air. For the next hour or two, the entire sky of the planet, from the North Pole to the South Pole, would have begun to glow a dull, menacing red. This created a brief, but global, thermal pulse of infrared radiation, an invisible wave of intense heat that baked the surface of the planet. The temperature at ground level would have soared to hundreds of degrees, the equivalent of being inside a pizza oven. For any animal not sheltered deep in a burrow or deep in a lake or river, the very air would have become lethal. And this global heat pulse had a final, terrible effect. It was the great, global incendiary. The lush, green leaves of the Cretaceous forests, dried to a crisp by the intense heat, would have spontaneously burst into flame. A global firestorm was ignited, a planetary inferno that would have consumed a significant portion of the world's terrestrial biomass. For the few, scattered creatures that had found shelter from this initial, terrifying rain of fire, the immediate danger had passed, but as they would eventually emerge, it would be into a new and even more terrifying world. The fires would have raged for days or weeks, but as they died down, the sky would not clear. The immense black clouds of soot from the burning of the world's forests, combined with the trillions of tons of fine, pulverized rock dust and sulfur aerosols that had been blasted into the stratosphere from the impact crater itself, now began to merge and spread. They formed a thick, dark, and impenetrable shroud that enveloped the entire planet. The sun, the source of all life and energy on Earth, was blotted out. A profound, unnatural, and absolute darkness fell over the world. The age of fire was over. The long, silent, and terrible impact winter was just beginning. The age of fire, as terrible as it was a brief and violent fever. The true agent of the great extinction was a far more patient and far more insidious killer. As the last of the global firestorms died down, the immense, black, choking clouds of soot, combined with the trillions of tons of fine, pulverized rock dust and sulfur aerosols that had been blasted into the stratosphere by the impact itself, now began to coalesce and spread. High above the reach of the weather, this vast cloud of debris formed a thick, stable, and globe-encircling shroud. The sun, the source of all life and energy on Earth, was blotted out. A profound, unnatural, and absolute darkness fell over the world. The impact winter had begun. Imagine the world in the first weeks following the great impact. A deep, unnatural night has fallen that will last for years. It is a darkness more profound than any natural night, a darkness so complete that a creature standing in an open plain would not be able to see its own hand in front of its face. The air is thick with the smell of smoke and strange, sulfurous chemicals, a fine, gray dust. The pulverized rock of the Yucatan Peninsula continues to settle out of the still air, coating the charred and broken landscape in a uniform blanket of pale death. And from the black sky, a greasy black rain begins to fall, a rain of soot and acid that poisons the very ground it touches. The only sound is the ceaseless, mournful whisper of a wind blowing across a dead and empty world. And with the darkness comes the cold. The Earth's warmth is derived almost entirely from the sun, and with that warmth now cut off, the planet's stored heat begins to radiate away into space. The warm, stable, greenhouse climate of the late Cretaceous collapses. Global temperatures plummet. Within weeks, the tropical and subtropical world of the dinosaurs is plunged into a deep and unrelenting freeze, with temperatures dropping below freezing, even at the equator. Snow, a phenomenon unknown to most of the Cretaceous world, now begins to fall, a strange, gray snow, mixed with the greasy black soot that continues to rain down from the darkened sky. The rivers and lakes begin to freeze over, and the once warm oceans grow a skin of ice in the temperate latitudes. This planetary winter is accompanied by a relentless chemical assault. The impact had vaporized a colossal volume of sulfate-rich gypsum rock, and the sulfur dioxide from this rock now combines with the water vapor in the atmosphere to form vast clouds of sulfuric acid. For months, perhaps for years, a relentless and intensely corrosive acid rain falls upon the planet. This acid rain poisons the soils, destroying their delicate microbial ecosystems. It leaches toxic heavy metals from the damaged land and washes them into the rivers, and it dramatically acidifies the surface layers of the global ocean, creating a lethal barrier for any marine life that had managed to survive the initial cataclysm. In this new, dark, cold, and poisoned world, the very foundation of life on Earth is severed. The great engine of photosynthesis, the process that had powered the planet's biosphere for over 3 billion years, sputters to a halt. In the oceans, the phytoplankton, the microscopic, floating algae that formed the vast, invisible meadows of the sea, die off in their trillions. With no sunlight, they can no longer create energy. The base of the entire marine food web is instantly and completely erased. The surface of the oceans becomes a clear, sterile, and lifeless graveyard. On the land, the same tragedy unfolds in slow motion. The plants that had miraculously survived the global firestorm now face a new and inescapable enemy. In the darkness and the freezing cold, they can no longer photosynthesize. They begin to wither and die. The great flowering magnolia trees drop their poisoned leaves. The lush fern prairies become black, frozen wastelands. The entire botanical kingdom of the Cretaceous, the product of 100 million years of evolution, is reduced to a silent, skeletal landscape of dead and dying wood. And with the death of the plants comes the slow, agonizing, and inevitable death of the great herbivores. Let us imagine a herd of triceratops, survivors who perhaps found shelter from the initial heat blast in a deep, shaded ravine. They emerge into this new world of darkness and cold. Their instincts drive them to search for the familiar cycads and palms that they need to fuel their 12-ton bodies, but they find nothing. They wander for weeks through the dark, frozen forests, their immense strength slowly failing them. The great, magnificent horned dinosaurs, the masters of defense, the titans of the Cretaceous plains, are brought low, not by a predator, but by the simple and absolute absence of food. They fall, one by one, into the gray, sooty snow, their great bodies a final, silent testament to a world that has vanished. The same fate befalls the vast, migratory herds of the duck-billed hadrosaurs and the impregnable, armored ankylosaurs. And as the herbivores die, so too must the carnivores. For a time, the apex predators, like Tyrannosaurus rex, would have found a world filled with the dying and the dead, a brief and final feast. But as the last of the great herbivores perish, the tyrant king finds itself the ruler of an empty and desolate kingdom. Its immense size and the high energy demands of its warm-blooded metabolism become its final, fatal curse. It cannot survive on the scraps of a dead world. The last of the great carnivorous dinosaurs, the culmination of 165 million years of predatory perfection, stalks the silent, frozen plains of a dead planet. for a time, before it too, finally, succumbs to the great, inexorable starvation. The collapse is absolute. In the seas, the ammonites, whose planktonic larvae depend on the now vanished phytoplankton, go extinct forever. The great marine reptiles, the mosasaurs, and the plesiosaurs, with the fish populations they preyed upon now collapsing, also disappear. The entire magnificent and complex ecosystem of the Mesozoic era, on land and in the sea, unravels, from the bottom up, until nothing is left. But this is not the end of the story of life. It is merely the end of a chapter. For in the deepest, darkest corners of this ruined world, life, in its most humble, resourceful, and resilient forms, had found a way to endure. The key to survival was not strength, or size, or specialization. It was the ability to live on the wreckage of the old world. A new food chain had been established. A food chain based not on sunlight and living plants, but on decay. The world was now filled with an almost limitless supply of dead organic matter. The rotting logs of the great forests, the decaying carcasses of the dinosaurs, and the very soil itself, rich with dormant seeds and hibernating insects. And it was the creatures that could tap into this detritus food web that would become the inheritors of the earth. The small, burrowing mammals, the freshwater turtles and crocodiles, and the seed-eating birds. For them, the long, dark, impact winter was not just an age of death, it was the beginning of their opportunity, the dawn of their own new world. The first dawn of the new era, the Cenozoic, illuminated a world of profound and quiet opportunity. The great filter of the extinction event had passed, and the survivors, the small, the resourceful, and the lucky, were now the inheritors of an entire planet. The niches once occupied by the most magnificent and diverse dynasty of creatures the earth had ever known were now vacant. The role of large herbivore, of apex predator, of every conceivable terrestrial form in between, was now an open position, waiting for a new applicant. And it was our own distant ancestors, the mammals, who would step forward to claim this inheritance. The first few million years of this new age, the Paleocene epoch, was a time of strange and experimental growth. As the planet slowly recovered from the impact winter, it entered a period of intense global warming, a hothouse world where lush, tropical, and subtropical forests spread from pole to pole. In the tangled, humid undergrowth of these new global jungles, the small, shrew-like mammals that had survived the extinction began to radiate with an explosive, creative energy. For the first time in 165 million years, they were free from the oppressive reign of the dinosaurs. They began to experiment with new diets, new lifestyles, and new body sizes. The first of these experiments produced a menagerie of strange and unfamiliar creatures. There were the first large mammalian herbivores, the pantodonts, like the clumsy, bear-like Barolambda, which browsed on the lush forest foliage. The role of top predator was taken up by the fearsome mesonychids, the first large mammalian predators, creatures like the wolf-like mesonyx, with its powerful bone-crushing jaws. And for a brief and glorious time, the dinosaurian legacy made a brief return as giant, flightless terror birds, like Gastornis in Europe, became formidable predators in their own right, a final, ghost-like echo of the great theropods. But as the Cenozoic progressed, through the Eocene and Oligocene epochs, these early experiments gave way to the great, modern lineages of mammals. The small, shrew-like generalists of the Paleocene evolved into a dazzling array of specialized forms. In the great spreading forests, the first primates, our own ancestors, perfected a life in the trees, with grasping hands and forward-facing eyes. On the newly forming grasslands, the first hoofed mammals appeared, tiny, forest-dwelling creatures, the size of a small dog, like Eohippus, began the long evolutionary journey that would lead to the modern horse. The first true carnivorans, the ancestors of our modern cats, dogs, and bears, evolved their specialized shearing teeth and replaced the more primitive mesonychids as the dominant predators. And in one of the most remarkable evolutionary stories of all time, one group of hoofed, land-dwelling mammals, creatures similar to a small wolf, began to return to the water. Over millions of years, they would evolve, step by step, from a semi-aquatic, crocodile-like predator, like Ambulocetus, the walking whale, into the fully aquatic, streamlined, and magnificent forms of the first true whales and dolphins, claiming the oceanic niches left vacant by the great marine reptiles. The age of mammals had truly and definitively arrived, a new and vibrant world order, built directly and immediately upon the ashes of the age of dinosaurs. But as we celebrate the triumphant rise of our own mammalian dynasty, we must pause, and we must remember the great extinction event that made our world possible was not the final word on the dinosaurs. Their story did not end 66 million years ago. It continues to this day, all around us. The great dynasty of the dinosaurs did not entirely perish. A single, small, and feathered branch of the theropod family tree, the birds, survived the cataclysm. And in doing so, they carried the legacy of their magnificent ancestors into our modern world. When you look at the skeleton of a mighty Tyrannosaurus rex, you see its bones are hollow, an adaptation for lightness and strength. And when you look at the skeleton of a tiny modern hummingbird, you see that its delicate bones are also hollow, built upon the very same ancient avian principle. When you see a fossil of a feathered velociraptor, with its complex, bird-like plumage, you are looking at the same structure that allows a modern eagle to soar. When you read of an oviraptorid dinosaur sitting on its nest, carefully brooding its eggs, you are witnessing the same parental care, the same instinct that you can see in a robin's nest in your own garden every spring. The dinosaurs are not an extinct group of ancient failures. They are one of the most successful animal dynasties of all time. They are not gone. They are with us right now. They are the 10,000 species of birds that fill our world with color and song and life. They are in every forest, on every continent, in every city park, and in every backyard. The ostrich, striding across the African savanna, is a living echo of the great bipedal theropods. The penguin, navigating the frigid Antarctic seas with its powerful wing-like flippers, is a living testament to the incredible adaptability of the dinosaurian form. The hawk, perched on a telephone pole, its sharp eyes scanning for prey, is a living tyrant. The dinosaur dynasty did not fall, it grew wings, and it inherited the sky. And so, our long and epic journey through the deep and silent corridors of time comes to its final, peaceful conclusion. We have traveled from the birth of a molten earth to the first spark of life. We have witnessed the poisoning and the greening of a planet. We have explored the strange, alien forms of the first animals and walked through the great coal swamps of the Carboniferous. We have survived the great dying, the greatest extinction of all time, and we have spent 165 million years in the majestic, awe-inspiring and terrifying world of the dinosaurs, a world that was their empire. We have watched their world flourish, and we have borne silent witness to its fiery and cataclysmic end. And we have seen, in the quiet dawn that followed, the rise of our own mammalian ancestors, and the enduring living legacy of the dinosaurs themselves. The story of the dinosaurs is a profound and humbling lesson in the nature of life on Earth. It is a story of incredible success and of catastrophic chance. It is a reminder that no reign, no matter how long or how mighty, is eternal, but it is also, and most importantly, a story of connection. The fall of the great dinosaurs was the single most important event that made our own world, the age of mammals, possible. Their story is the great and tragic preface to our own. The history of life on this planet is a single, immense, and unbroken thread. It connects the atoms in our bodies to the hearts of long-dead stars. It connects the very cells that power us to ancient microbes that were engulfed in a symbiotic partnership 2 billion years ago. And it connects us, the quiet inheritors of a fallen world, to the last mighty triceratops that ever walked the earth. As you now drift into a deep and final, peaceful sleep, may you feel the quiet wonder of that immense, unbroken story, and your own small but precious place within it. But the first few million years of the new era, the Paleocene epoch, was a world of strange and quiet recovery. The fern spike, that initial monotonous greening of the ash-covered continents, slowly gave way to the return of the forests. But these were not the complex, diverse woodlands of the late Cretaceous. They were strange, low-diversity forests, often dominated by just a few hardy, fast-growing species of disaster taxa. Imagine walking through a woodland where almost every tree is the same, a world of ancient relatives of walnuts and sycamores, their canopies creating a deep and uniform shade. The ground beneath is still covered in a thick carpet of ferns, but now, the first flowering shrubs and herbs are beginning to push their way through, their small, simple blossoms adding the first touches of new color to a world that had been rendered in monochrome. The air itself was different. The immense global firestorms and the vaporization of carbonate rocks had released a colossal amount of carbon dioxide into the atmosphere. The world of the Paleocene was a hothouse, a planet with a supercharged greenhouse effect. It was significantly warmer than our own modern world, and this warmth was distributed almost evenly across the globe. There were no polar ice caps, and lush, subtropical, and even tropical forests grew in the high latitudes of what are now Alaska, Greenland, and Antarctica. Fossilized palm trees and the remains of crocodile-like reptiles found in these polar regions are a silent testament to a world that was, for a time, a global jungle. And it was in these strange, warm, and silent global forests that the great mammalian experiment began. The small, shrew-like creatures that had scurried from their burrows into the fern world now found themselves in a paradise of opportunity. The world was full of plants, with no large herbivores to eat them, and the world was empty of large predators. For the first time, being small was no longer a requirement for survival, and so the mammals began to grow. This first great evolutionary radiation was not a neat and orderly affair. It was a chaotic, experimental, and often bizarre explosion of new forms, as evolution threw everything it had at the wall to see what would stick. Many of these first experiments were evolutionary dead ends, strange creatures that would flourish for a few million years in this strange new world before vanishing forever. Let us meet some of these first pioneers. Browsing on the soft leaves and fruits of the new forests was a creature like Panta. It was one of the first mammals to achieve a respectable size, perhaps as large as a modern sheep. It was a Pantodont, an early, experimental group of herbivores. It was a clumsy, stout-bodied animal, walking on 5-toed flat feet, with a small, simple brain and teeth that were not yet highly specialized for grinding tough plants. It was not a fast runner, nor was it a particularly intelligent animal. It didn't need to be. In a world with few predators, it was enough to simply be large. Another of these strange, early herbivores was Tania. This was a powerfully built creature, the size of a pig, with immense forelimbs and huge, clawed hands. It was a digger, likely using its great claws to unearth the tough roots and tubers that were abundant in the forest floor. Its teeth were strange and peg-like, and they grew continuously throughout its life, an adaptation to a diet of abrasive, gritty food. With this new and expanding buffet of herbivores, the first true mammalian predators also began to evolve, but these were not the sleek, efficient hunters of our modern world. The apex predators of the Paleocene were a strange and formidable group called the Mesonychids. A creature like Mesonyx was the size of a wolf, but it was not a wolf. Its head was large and long, its brain was small, and its teeth were simple, crushing triangles of bone. Most strangely of all, its feet did not end in claws, but in small, hoof-like toes. It was a wolf in sheep's clothing, a powerful hunter that likely ran down the slow, clumsy pantodonts of its time. And in the trees, a new kind of mammal was beginning its own quiet revolution. These were the Plesiadapiforms, a diverse and successful group of primate-like mammals. A creature like Plesiadapis looked something like a squirrel, with a long, bushy tail and claws for climbing, but its teeth and skull show the first, faint hints of the features that would one day define our own primate lineage. They were not our direct ancestors, but they were our close cousins, and their flourishing in the Paleocene forests was the first chapter in the long and winding story that would 60 million years later lead to us. But the most spectacular and terrifying predators of the Paleocene were not mammals at all. They were a final, magnificent echo of the age of dinosaurs. With the great theropods gone, the niche of the large terrestrial predator was for a time reclaimed by the birds. These were the terror birds, giant, flightless descendants of the smaller birds that had survived the extinction. In South America and Europe, a creature like Gastornis, a 2-meter tall behemoth, stalked the forests. It had a massive, powerful head and a huge hooked beak, a weapon capable of delivering a devastating, axe-like blow. For millions of years, this great dinosaurian ghost was the undisputed king of the Paleocene jungle, a final, triumphant, and terrifying reminder of the dynasty that the world had lost. And what of the other great survivors? In the warm, fresh waters of the recovering world, the crocodiles, alligators, and their relatives thrived. They had passed through the extinction with relative ease, and in the hothouse world of the Paleocene, they diversified and spread, becoming the dominant aquatic predators across the globe. Some, like the mighty Titanosaur, a colossal snake from South America that could reach lengths of over 13 meters or 43 feet, became the largest predators of their kind. The world of the Paleocene was a strange and unbalanced one, a world where the old guard of the reptiles still held sway in the water and the air, while the new and experimental mammals were just beginning to find their feet on the land. This strange, experimental, and hothouse world, this first chapter of the Cenozoic, lasted for 10 million years. It was an age of recovery, a time for the biosphere to heal its wounds and to begin the long process of rebuilding the complexity that had been lost. It was an age of ghosts, haunted by the memory of the dinosaurs, and an age of pioneers, as our own mammalian ancestors took their first tentative steps out of the shadows and into the light. But the stability of this new world was itself an illusion. The intense greenhouse climate of the Paleocene was about to be pushed into an even more extreme state, a planetary fever spike that would once again reshape the world and set the stage for the next great chapter in the age of mammals, the cathedrals of the Ice Age. The world we now enter is a world of profound and unsettling simplicity. For 100 million years, the Earth had been a place of intricate complexity, of vast herds and mighty predators, of ecosystems woven from a million different threads of interaction. Now that tapestry had been burned away, and life had to begin weaving itself anew from the few hardy threads that remained. This first chapter of the Cenozoic, the Paleocene epoch, which lasted for 10 million years, was an age of recovery, of experimentation, and of strange transitional beauty. Let us first revisit the landscape of this newborn world. The fern spike, that first desperate greening of the poisoned soils, was a temporary phase, as the planet's climate, freed from the chilling grip of the impact winter, began to stabilize and warm. The true survivors of the botanical kingdom began their slow reconquest. The first forests to rise from the ashes were not the familiar, broad-leafed woodlands of today. They were strange, low-diversity forests, often dominated by just a few hardy, fast-growing species of disaster taxa. Imagine walking through a woodland where almost every tree is the same, a world of ancient relatives of walnuts and sycamores, their canopies creating a deep and uniform shade. The ground beneath is still covered in a thick carpet of ferns, but now the first flowering shrubs and herbs are beginning to push their way through, their small, simple blossoms adding the first touches of new color to a world that had been rendered in monochrome. The air itself was different. The immense global firestorms and the vaporization of carbonate rocks had released a colossal amount of carbon dioxide into the atmosphere. The world of the Paleocene was a hothouse, a planet with a supercharged greenhouse effect. It was significantly warmer than our own modern world, and this warmth was distributed almost evenly across the globe. There were no polar ice caps, and lush, subtropical, and even tropical forests grew in the high latitudes of what are now Alaska, Greenland, and Antarctica. Fossilized palm trees and the remains of crocodile-like reptiles found in these polar regions are a silent testament to a world that was, for a time, a global jungle. And it was in these strange, warm, and silent global forests that the great mammalian experiment began. The small, shrew-like creatures that had scurried from their burrows into the fern world now found themselves in a paradise of opportunity. The world was full of plants, with no large herbivores to eat them, and the world was empty of large predators. For the first time, being small was no longer a requirement for survival, and so the mammals began to grow. This first great evolutionary radiation was not a neat and orderly affair. It was a chaotic, experimental, and often bizarre explosion of new forms as evolution threw everything it had at the wall to see what would stick. Many of these first experiments were evolutionary dead ends, strange creatures that would flourish for a few million years in this strange new world before vanishing forever. Let us meet some of these first pioneers. Browsing on the soft leaves and fruits of the new forests was a creature like Pantolambda. It was one of the first mammals to achieve a respectable size, perhaps as large as a modern sheep. It was a Pantodon, an early, experimental group of herbivores. It was a clumsy, stout-bodied animal, walking on 5-toed flat feet, with a small, simple brain and teeth that were not yet highly specialized for grinding tough plants. It was not a fast runner, nor was it a particularly intelligent animal. It didn't need to be. In a world with few predators, it was enough to simply be large. Another of these strange early herbivores was Titanosaur. This was a powerfully built creature, the size of a pig, with immense forelimbs and huge clawed hands. It was a digger, likely using its great claws to unearth the tough roots and tubers that were abundant in the forest floor. Its teeth were strange and peg-like, and they grew continuously throughout its life, an adaptation to a diet of abrasive, gritty food. With this new and expanding buffet of herbivores, the first true mammalian predators also began to evolve, but these were not the sleek, efficient hunters of our modern world. The apex predators of the Paleocene were a strange and formidable group called the Mesonychids. A creature like Mesonyx was the size of a wolf, but it was not a wolf. Its head was large and long, its brain was small, and its teeth were simple, crushing triangles of bone. Most strangely of all, its feet did not end in claws, but in small hoof-like toes. It was a wolf in sheep's clothing, a powerful hunter that likely ran down the slow, clumsy pantodonts of its time. And in the trees, a new kind of mammal was beginning its own quiet revolution. These were the Plesiadapiforms, a diverse and successful group of primate-like mammals. A creature like Plesiadapis looked something like a squirrel, with a long, bushy tail and claws for climbing, but its teeth and skull show the first, faint hints of the features that would one day define our own primate lineage. They were not our direct ancestors, but they were our close cousins, and their flourishing in the Paleocene forests was the first chapter in the long and winding story that would 60 million years later lead to us. But the most spectacular and terrifying predators of the Paleocene were not mammals at all. They were a final, magnificent echo of the age of dinosaurs. With the great theropods gone, the niche of the large terrestrial predator was, for a time, reclaimed by the birds. These were the terror birds, giant, flightless descendants of the smaller birds that had survived the extinction. In South America and Europe, a creature like Gastornis, a 2-meter-tall behemoth, stalked the forests. It had a massive, powerful head and a huge hooked beak, a weapon capable of delivering a devastating, axe-like blow. For millions of years, this great dinosaurian ghost was the undisputed king of the Paleocene jungle, a final, triumphant, and terrifying reminder of the dynasty that the world had lost. And what of the other great survivors? In the warm, fresh waters of the recovering world, the crocodiles, alligators, and their relatives thrived. They had passed through the extinction with relative ease, and in the hothouse world of the Paleocene, they diversified and spread, becoming the dominant aquatic predators across the globe. Some, like the mighty Titanosaur, a colossal snake from South America that could reach lengths of over 13 meters, or 43 feet, became the largest predators of their kind. The world of the Paleocene was a strange and unbalanced one, a world where the old guard of the reptiles still held sway in the water and the air, while the new and experimental mammals were just beginning to find their feet on the land. This strange, experimental, and hothouse world, this first chapter of the Cenozoic, lasted for 10 million years. It was an age of recovery, a time for the biosphere to heal its wounds and to begin the long process of rebuilding the complexity that had been lost. It was an age of ghosts, haunted by the memory of the dinosaurs, and an age of pioneers, as our own mammalian ancestors took their first tentative steps out of the shadows and into the light. But the stability of this new world was itself an illusion. The intense greenhouse climate of the Paleocene was about to be pushed into an even more extreme state, a planetary fever spike that would once again reshape the world and set the stage for the next great chapter in the age of mammals. The quiet, recovering world of the Paleocene, with its simple forests and its clumsy, archaic beasts, was a transitional age, a 10 million year-long breath between two worlds. The planet was still in the grip of a powerful greenhouse effect, the long-lingering atmospheric legacy of the Great Extinction. But this warmth was about to intensify to a level not seen in nearly 100 million years. Around 56 million years ago, at the boundary between the Paleocene and the subsequent Eocene epoch, the Earth's climate system was pushed past a critical tipping point. Over a period of just a few thousand years, a geologically instantaneous moment, a colossal amount of carbon was injected into the atmosphere. The most likely source was a massive release of frozen methane hydrates from the deep seafloor, a potent greenhouse that triggered a runaway global warming event. This was the Paleocene-Eocene thermal maximum, or PETM, a brief but violent planetary fever spike that would usher in the true golden age of the Cenozoic hothouse. The Eocene epoch was the warmest period of the last 66 million years. It was a world entirely without ice. The average global temperature was perhaps 14 degrees Celsius, or 25 degrees Fahrenheit, warmer than it is today. This warmth was distributed almost evenly across the globe. The temperature difference between the equator and the poles was minimal, and the result of this immense global warmth was a world of almost unimaginable greenery. Lush, dense, and sprawling tropical and subtropical rainforests covered almost every corner of the land, from the shores of South America to the heart of Asia, and from the coast of Australia to the now ice-free lands of the high Arctic and Antarctica. We know this because the fossil record from these polar regions tells an unambiguous story. In places like Ellesmere Island in the Canadian Arctic, a land that is today a barren expanse of ice and rock, paleontologists have unearthed the fossilized remains of immense cypress trees, of palm trees, and of the alligators and turtles that lived in the warm, swampy waters beneath them. The Eocene was for a time a true jungle planet, and in this global jungle, the strange, experimental mammals that had first appeared in the Paleocene reached their bizarre and spectacular peak before giving way to a new and more sophisticated generation of creatures. The role of the large herbivore was now filled by a truly fantastic group of animals, called the Dinosaurata, the terrible horns. Their most famous member was Uintatherium. This was a creature the size of a modern rhinoceros, a bulky, powerful herbivore that roamed the forests of North America and Asia. Its head was its most striking feature, adorned with 6 strange, bony, knob-like horns, and a pair of long, saber-like canine teeth that pointed downwards from its upper jaw. It was a bizarre and intimidating beast, a true giant of the Eocene, but it was also a representative of a dying dynasty. Its brain was remarkably small for its body size, and its teeth were simple and inefficient. It was a first, clumsy draft of a large mammal. The role of the apex predator was also still held by archaic lineages. The Mesonicids continued to thrive for a time, but the most formidable hunters of the early Eocene were the creodonts. A creature like Hyenodon, despite its name, was not a true hyena, but a member of this extinct order of carnivorous mammals. Some species of Hyenodon, grew to the size of a large bear, with a massive skull and powerful jaws lined with teeth that were designed not for complex slicing, but for simple, brutal, bone-crushing power. These archaic mammals, both the strange horned herbivores and the powerful, brutish predators, were the rulers of the early Eocene world, but their reign was destined to be a short one, for in the dense, humid undergrowth of their great jungle world, a new and more sophisticated generation of mammals was quietly rising. The warm, stable, and productive world of the Eocene was the crucible for the great radiation of modern mammalian orders. At the beginning of this epoch, a host of new and familiar lineages appeared almost simultaneously in the fossil record across the northern continents. The first of the perissodactyls, the odd-toed ungulates, appeared. Among them were the first hornless rhinoceroses and the colossal, extinct brontotheres, like Megacerops, a giant with a strange, forked, bony horn on the end of its nose. But the most famous of these were the first horses, a creature like Hyracotherium, often called Eohippus, or the dawn horse, was a small, delicate animal, no larger than a fox. It had 4 toes on its front feet and 3 on its back, and it did not graze on grass, but browsed on the soft leaves and fruits of the dense forest undergrowth. It was a creature perfectly adapted to a life of quiet, hiding in the Eocene jungle. At the same time, the first artiodactyls, the even-toed ungulates, appeared. These were the ancestors of our modern deer, camels, pigs, and cattle. Early forms, like the rabbit-sized Diacodexis, were also small, forest-dwelling creatures, but they possessed a key advantage that would eventually allow them to become the most successful large herbivores on the planet: a more advanced and efficient digestive system. And in the great, globe-spanning canopy of the Eocene rainforests, our own lineage, the primates, was experiencing its golden age. The world was filled with a diverse array of lemur-like and tarsier-like creatures, perfectly adapted to a life of climbing, leaping, and feeding on the abundant fruits and insects of the treetops. The famous Ida fossil, a beautifully preserved specimen of a creature named Darwinius, gives us an incredible snapshot of one of these early primates, from its grasping hands and feet to the faint outline of its fur and the fossilized remains of its last meal of fruits and leaves. And as these new, more advanced herbivores began to spread, so too did a new generation of predators. The first of the carnivorans appeared, the ancestors of our modern cats and dogs. A creature like Myacius, small and weasel-like, possessed a key innovation that would give its descendants a decisive edge. Its teeth were evolving into the specialized, slicing blades known as carnassials, a far more efficient tool for shearing flesh than the simple, crushing teeth of the older creodonts. And in the skies, the first true bats, like Icaronicturus, took to the wing, their fossilized remains from the Eocene already showing the fully formed wings and enlarged cochleas in the inner ear that proved they were already masters of both powered flight and echolocation 50 million years ago. But the most incredible and dramatic evolutionary story of the Eocene did not take place on the land or in the air. It took place in the water. One group of artiodactyl mammals, a lineage of hoofed, land-dwelling creatures, began to return to the sea, initiating one of the most complete and beautifully documented evolutionary transitions in the entire fossil record. The story begins with a creature like Pakicetus. From the early Eocene of Pakistan, it looked like a small wolf, and it lived on the land, near freshwater streams. But the bones of its inner ear had a unique structure, a signature adaptation for hearing underwater that is found only in one other group of animals in all of history: the cetaceans, the whales, dolphins, and porpoises. A few million years later, we find Ambulocetus, the walking whale. This was a creature the size of a large sea lion, with a long crocodile-like snout and powerful webbed feet. It could still walk, clumsily, on the land, but in the water, it was a powerful and graceful swimmer, using its huge feet and a powerful, undulating motion of its spine to propel itself through the water, an ambush predator that was equally at home in both realms. From there, the transition accelerated. Creatures like Rhodocetus became even more marine, with a more powerful tail for swimming and hind limbs that were shrinking and becoming less useful on land. And this journey culminates in the late Eocene with the magnificent and terrifying Basilosaurus. This was a true, fully aquatic whale, but it looked nothing like a modern one. Its body was immense and incredibly long and serpentine, up to 18 meters or 60 feet in length. It was the apex predator of the late Eocene seas, and yet it still carried the ghost of its terrestrial past. Near the back of its long, sinuous body, it still possessed a pair of tiny, perfectly formed, but completely useless hind legs, a final, ghostly echo of a time, 10 million years before, when its ancestors had walked on the land. This was the world of the Eocene, a vibrant, warm, and stable jungle planet, a world where the first, strange experiments of the mammalian radiation gave way to the great modern lineages that would define the rest of our age. The world of the Eocene, with its magnificent, serpentine whale, Basilosaurus, its tiny, forest-dwelling horses, and its canopy filled with the first primates, was a world at its peak, but it was a world living on borrowed time, deep in the southern hemisphere. A geological event of profound significance was slowly unfolding, an event that would pull a great climatic lever and plunge the entire planet into a new state of being. Throughout the early Cenozoic, the great southern continent of Antarctica, though located over the South Pole, had remained largely ice-free, connected by land bridges to both South America and Australia. This connection had a critical effect on the world's oceans. Warm, tropical ocean currents from the equator could flow southwards, bringing their heat to the Antarctic coast, keeping the continent temperate and preventing the formation of large ice sheets. But as the Eocene progressed, this ancient connection began to break. First, Australia drifted northwards, opening up a deep oceanic gateway. Then, more slowly, South America pulled away, and the Drake Passage, the waterway between the tip of South America and the Antarctic Peninsula, opened for the first time. This was a moment of profound and irreversible change for the planet's climate engine. With Antarctica now completely isolated in the Southern Ocean, a new and powerful ocean current was born, the Antarctic Circumpolar Current. This great circular current began to flow, unimpeded, around the entire Antarctic continent. It acted as a colossal thermal barrier, a wall of cold water that prevented the warm currents from the equator from ever reaching the southern pole again. Isolated from the warmth of the tropics, the continent of Antarctica began to freeze. Over a period of a few 100,000 years, a geologically brief moment, colossal ice sheets, kilometers thick, grew and spread across the land. The world had grown a new pole cap. This event, which occurred around 34 million years ago, at the boundary between the Eocene and the subsequent Oligocene epoch, marked the great turning point of the Cenozoic. The planet shifted, permanently, from a warm, wet, greenhouse state into a cooler, drier, icehouse state. This was not a brief cold snap, it was a fundamental reorganization of the global climate system. This profound climatic shift had a devastating effect on the life that had evolved in the stable hothouse of the Eocene. The great, global, pole-to-pole rainforests could not survive in this new, cooler, and more seasonal world. They began to shrink and retreat, becoming confined to the warmer, wetter equatorial regions. And as the forests retreated, a new and revolutionary kind of habitat began to spread across the newly opened landscapes. This was the birth of the grasslands. These first grasslands of the Oligocene were not the vast, treeless prairies of today. They were likely more like open woodlands or savannas, a patchwork of grassy clearings interspersed with stands of hardy, drought-tolerant trees. But their appearance was a momentous event in the history of life. Grass is a fundamentally different kind of plant from the soft leaves of the forest. It is tough, fibrous, and filled with abrasive silica particles. It grows not from the tip of a leaf, but from the base, meaning it can be continuously grazed and still recover. This new, tough, and resilient vegetation created a whole new set of evolutionary challenges and opportunities for the world's herbivores. The great climatic and botanical revolution that marked the beginning of the Oligocene triggered a major extinction event, an event known in Europe as the Grand Coupure or the Great Break. The archaic mammals of the Eocene, with their small brains and simple, inefficient teeth, were not well equipped to deal with this new world. The strange, six-horned Euenterium and its relatives, the Brontotheres, and the brutish, carnivorous creodonts, all creatures of the ancient jungle, could not adapt to the new, tougher food sources and the more open landscapes. They faded into extinction, a failed first draft of the age of mammals. Their place was taken by the new, more modern mammals that had been living in their shadows. For these creatures, the new world of open grasslands was a world of incredible opportunity, and they adapted to it with spectacular success. The age of the archaic beasts was over. The age of the true mammals had begun. Among the herbivores, this was the beginning of the great age of the grazers. The horses, which had been small, cat-sized, forest-dwelling browsers, now began to adapt to a life on the plains. A creature like Mesohippus was larger than its ancestors. Its legs were longer and more slender for running, and it was losing its side toes, concentrating its weight on a single central toe that would one day become a hoof. Most importantly, its teeth were changing, becoming taller and more robust, with thicker layers of enamel, the first steps towards the high-crowned, grinding teeth needed to cope with a lifetime of eating tough, abrasive grass. The rhinos also flourished in this new world, diversifying into a host of new forms, from small, running rhinos to the largest land mammal of all time, the colossal, hornless Paracitherium, a giraffe-like behemoth that browsed on the tops of the trees in the open woodlands of Asia. The first true camels and deer appeared, also adapting to the new open habitats. And in North America, the landscape was dominated by a strange and incredibly successful group of herbivores called the Oreodonts. A creature like Maricoidon looked something like a sheep or a pig, and vast, sheep-like herds of these animals roamed the new savannas in their millions, becoming the primary food source for a new generation of predators. And these new predators were the true carnivorans. With the old creodonts gone, the ancestors of our modern cats and dogs rose to prominence. They were faster, more agile, and more intelligent hunters, perfectly suited for chasing down prey in the open. There were the first Amphicyonids, the bear dogs, large, powerful predators that combined the traits of both groups. And there were the first Nimravids, the false saber-toothed cats. A creature like Hoplophonius was a sleek and powerful ambush predator, with a pair of long, flattened, saber-like canine teeth, a stunning example of convergent evolution with the true saber-toothed cats that would evolve millions of years later. This was the new world of the Oligocene, a world that was, for the first time, truly modern in its feel. It was a world of vast, open spaces, of sweeping grasslands, rustling in the wind. It was a world of great, migratory herds of grazing animals, of horses, rhinos, and ariodonts. And it was a world of swift, intelligent, and pack-hunting predators. The journey into the Miocene epoch, which began around 23 million years ago, saw these trends accelerate and intensify. The world continued its slow, drying, and cooling trend. The grasslands and savannas became the dominant biome across vast swathes of the globe. This was the golden age of the grasslands, and it sparked a new and intense evolutionary arms race between the grazers and their predators. The herbivores perfected their adaptations for a life of eating grass and running from danger. The horse lineage produced Merychippus, the first true grazing horse with the high-crowned, cement-covered teeth needed to resist a lifetime of abrasive wear. The artiodactyls, the even-toed ungulates, perfected their multi-chambered, ruminating stomachs, which allowed them to efficiently extract every last bit of nutrition from the poor-quality grass. The first true elephants, the Gomphotheres, appeared with strange, shovel-like lower tusks for digging up roots, and the plains were stalked by an even more terrifying menagerie of predators. The bear dogs grew to immense sizes, and the first true saber-toothed cats, like Machaeretus, appeared, perfecting the art of the ambush hunt. And it was into this new, challenging, and dangerous world of the open plains that our own ancestors, the primates, were now drawn. The great global cooling had caused the vast, tropical rainforests to shrink and fragment, confining them to the equatorial regions of Africa and Asia. The world of the apes, the world of the treetop canopy, was disappearing. The Miocene was a time of great ape diversity, but as their forest homes shrank, these apes were faced with a profound evolutionary crossroads. One path was to retreat with the forests, to become specialists of the shrinking woodland habitats. This was the path taken by the ancestors of our modern orangutans in Asia and the ancestors of the gorillas and chimpanzees in Africa. The other path was a far more dangerous and uncertain one. It was to leave the relative safety of the trees and venture out into the new, open, and dangerous world of the savanna. This was the path that would eventually lead to us. The challenges of this new world were immense. On the savanna, there were few trees to escape into, and our ancestors would have been slow, clumsy, and vulnerable in the open, easy prey for the new, fast-running saber-toothed cats and bear dogs. But the opportunities were also great. The savanna offered new food sources, like roots, tubers, and the carcasses left behind by the great predators. To exploit these resources, a new way of moving and a new way of being was required. It was at the very end of this long Miocene epoch that we find the first tantalizing evidence of the most important adaptation in our own lineage's history. From fossils found in the ancient soils of Africa, fossils like the skull of Sahelanthropus from Chad or the femur of Oreron from Kenya, we see the first faint hints of bipedalism, the ability to walk upright on two legs. The evidence is fragmentary, but it suggests that around 6 to 7 million years ago, a group of African apes had begun to experiment with a new form of locomotion. This single, momentous shift was the first step on the road to becoming human. It was a humble and hesitant step, taken by a small and vulnerable ape on the edge of a shrinking forest, in a world that was growing ever colder and drier. The world we now enter is a world on the brink of ice. The Pliocene epoch, which began around 5.3 million years ago, was an age of accelerating change. The global cooling and drying trend that had begun in the Oligocene continued, and the continents were now very nearly in their modern positions. A single crucial geological event during this time would act as the final trigger for the coming ice. The Isthmus of Panama, the thin land bridge connecting North and South America, rose from the sea. This seemingly small event had a profound and planet-altering effect on the circulation of the world's oceans. It shut down the flow of warm, tropical water between the Atlantic and the Pacific. This rerouted ocean currents on a global scale, pushing more warm, salty water northwards into the North Atlantic. This warm water evaporated, creating more moisture in the atmosphere, which then fell as immense amounts of snow over the northern continents. Year after year, the snow accumulated, compressing into vast sheets of ice. The ice ages were about to begin. But before the ice took hold, the Pliocene was the final, golden age of the global savanna fauna. The grasslands and open woodlands that had been born in the Oligocene now reached their maximum extent, creating a world of incredible biodiversity, a world of giants that rivaled, and in some cases, even surpassed, those of today. The great grazing herds of the Pliocene were a spectacle of immense scale and diversity. This was the world of the true megafauna. The horse lineage, which had been adapting to a life of grazing for millions of years, now produced the first truly modern, single-toed horses, like Pliohippus. They were fast, efficient runners, their high-crowned teeth perfectly suited for a lifetime of grinding tough, abrasive grass. The ancestors of our modern elephants, the proboscideans, diversified into a host of spectacular forms. In the savannas of Africa and Eurasia, there were giants like Dinotherium, an immense beast with strange, downward curving tusks on its lower jaw, which it may have used to strip bark from trees. With the formation of the Isthmus of Panama, a great migration began. Animals from North America, like horses, camels, and saber-toothed cats, moved south, and from the south, a host of strange and unique creatures, which had evolved in isolation for millions of years, moved north. Among them were the colossal giant ground sloths, like the mighty Megatherium, a creature as large as an elephant that could stand on its hind legs to browse on trees. And there were the Glyptodonts, car-sized relatives of armadillos, covered in a solid, dome-like shell of bony armor. To hunt these magnificent herbivores, the predators had also reached a new peak of sophistication. The great saber-toothed cats were now the undisputed kings of the ambush. A cat like Smilodon was a powerhouse of a predator. It was not a fast runner, but was built with the immense muscular power of a bear. It would have used its strength to wrestle its large, thick-skinned prey to the ground before delivering a single, precise, and fatal bite with its colossal 7-inch-long canine teeth. The open plains were also patrolled by swift, pack-hunting dire wolves and giant, bone-crushing hyenas, and it was into this vibrant, beautiful, and incredibly dangerous world that our own ancestors now fully emerged. This was the age of the Australopithecines, the southern apes. For several million years, these remarkable creatures thrived in the savannas and open woodlands of Africa. They were a diverse group, not a single species, but a whole family of bipedal apes, our closest and most well-known ancient relatives. The most famous of all is a single, partial skeleton discovered in the Afar region of Ethiopia in 1974. Her discoverers named her Lucy. She belonged to the species Australopithecus afarensis, and she lived around 3.2 million years ago. Her skeleton is one of the most important fossils ever found because it provides undeniable proof that our ancestors were walking upright, on two legs, long before they developed large brains or made stone tools. Lucy's anatomy is a beautiful mosaic of ancient and modern traits. Her pelvis is short and bowl-shaped, like a human's, a clear adaptation for balancing the torso during bipedal walking. Her knee joint and the angle of her femur show that she could lock her legs straight, allowing her to stand and walk with an efficient, striding gait. But her arms were still long and powerful, and her finger and toe bones were curved, like those of a chimpanzee. This tells us that she was still an adept and powerful climber. Lucy and her kind lived a life of duality, a life spent both walking on the ground during the day to forage for food, and likely retreating to the safety of the trees at night to sleep, away from the saber-toothed cats and hyenas that prowled the darkness. And we know she was not alone. In Laetoli, Tanzania, another discovery of breathtaking significance was made, preserved in a layer of ancient, hardened, volcanic ash. A set of footprints was found, dating back 3.6 million years. These were the Laetoli footprints. They show two, perhaps three, of our Australopithecus afarensis ancestors, walking together across a damp, ashen plain. Their prints are unmistakably human-like, with a clear arch and a forward-pointing big toe. It is a single, frozen moment in time, a poignant and powerful testament to our deep past, a record of our ancestors walking together across a long-vanished world. This successful group of upright apes diversified into many forms. There were the gracile forms, like Lucy, and there were the robust forms, like Paranthropus, which had enormous, dish-shaped faces, immense molar teeth, and a great, bony crest on the top of their skulls for anchoring massive chewing muscles. Adaptations for a diet of tough, fibrous, low-quality vegetation. And at some point during this time, a new and revolutionary behavior appeared. Around 3.3 million years ago, we find the first simple stone tools. These are not the sophisticated hand axes of later humans, but simple, battered cobbles and sharp-edged flakes used for cracking open nuts or stripping meat from bones. This was the dawn of technology, the first faint glimmer of the ingenuity that would one day define our lineage. As the Pliocene drew to a close, the global cooling trend that had been building for millions of years finally reached its tipping point. Around 2.6 million years ago, the great ice ages of the Pleistocene epoch began. The vast ice sheets that had already formed on Antarctica now began to grow in the northern hemisphere as well. Colossal glaciers, the Laurentide and Cordilleran ice sheets in North America, and the Scandinavian ice sheet in Europe began to advance southwards, grinding and scouring the land, their immense weight depressing the Earth's crust beneath them. This was not a single, continuous winter. The Pleistocene was a dramatic and unstable time of oscillating climates, of long, cold glacial periods, where the ice sheets would advance, and shorter, warmer, interglacial periods, where they would retreat. We are living in one of those warm interglacial periods right now. But for much of the last 2.5 million years, the Earth has been a much colder place. This new, challenging world of ice and stone would be the final crucible, the ultimate test for our own bipedal, tool-making ancestors. A new, more intelligent, and more adaptable kind of hominin was about to emerge on the cold savannas of Africa, a creature that would learn to master fire, to create more sophisticated tools, and to begin a journey that would eventually take it out of its African homeland and across the entire globe. The world of the Middle Pleistocene, which began around 780,000 years ago, was a world in the grip of the most intense glacial cycles of the last 66 million years. The slow, predictable wobbles in the Earth's orbit around the Sun now conspired to create long and punishing ice ages, punctuated by brief, warm interglacial periods. During a glacial maximum, the planet was a profoundly different place. Colossal ice sheets, kilometers thick, smothered the northern continents. The Laurentide ice sheet covered all of modern-day Canada and stretched south to where New York City now stands. In Europe, the Scandinavian ice sheet covered the British Isles and all of northern Europe. So much of the world's water was locked up in these glaciers that global sea levels fell by over 120 meters, creating vast new areas of land and altering the shape of the continents. The world beyond the ice was a cold, dry, and windswept place, a vast treeless biome known as the Mammoth Steppe, which stretched from Western Europe all the way across Asia and over the vast exposed land bridge of Beringia into North America. It was in this challenging and unforgiving world that the descendants of Homo erectus continued to evolve in Europe and the Middle East. A new and highly specialized kind of human emerged, a creature perfectly and beautifully adapted to a life in the cold. These were the Neanderthals. For hundreds of thousands of years, the Neanderthals, Homo neanderthalensis, were the undisputed masters of Ice Age Eurasia. Their very bodies were a testament to their profound adaptation to a cold and brutal environment. They were shorter and far more robustly built than modern humans, with wide, barrel-shaped chests and short, powerful limbs, a body plan that conserved heat with incredible efficiency. Their bones were incredibly thick, their bodies powerfully muscled, the skeletons of natural powerlifters, a physique necessary for a life of close-quarters hunting of giant and dangerous Ice Age beasts. Their skulls were also distinct, long and low, with a prominent brow ridge and a large projecting nose that was likely filled with a complex network of blood vessels, a biological radiator designed to warm and moisten the frigid, dry air of the Ice Age before it reached their lungs. And within that long skull was a brain that was, on average, even larger than our own. The Neanderthals were not the brutish, hunched-over cavemen of old cartoons. They were a different, highly intelligent, and incredibly successful form of humanity. Their intelligence is written in the stone tools they left behind. The Neanderthals were masters of a sophisticated tool-making technology known as the Mousterian tradition. This was a significant leap beyond the simple hand axes of their ancestors. It involved a complex and abstract process of preparing a core of flint, carefully shaping it, before striking off a final perfectly formed flake that would be used as a spear point or a cutting tool. This technique, known as the level-O's technique, required foresight, planning, and a deep understanding of the properties of stone. They were also formidable hunters. Isotopic analysis of their bones shows that they were top-level carnivores, their diet consisting almost entirely of the meat of the great megafauna of the Ice Age. They hunted woolly mammoths, woolly rhinos, giant cave bears, and vast herds of bison and reindeer, and because their tools were designed for thrusting, not throwing, they had to hunt these immense and dangerous animals up close, a life of incredible bravery and constant, brutal physical risk. But perhaps the most profound evidence of their humanity is found in the way they lived and the way they died. We have found the fossilized remains of old Neanderthals, individuals who had suffered debilitating injuries like withered arms or crippling arthritis, yet who lived on for years, long after they would have been able to fend for themselves. This is a clear and poignant sign that they were cared for by their social group, that they were looked after and fed, a testament to a deep and powerful sense of empathy and community. And we know that they buried their dead. In caves across Europe and the Middle East, we have found Neanderthal skeletons that were deliberately and carefully placed in graves, some in a sleeping posture, some accompanied by simple grave goods like stone tools or animal bones. This act of intentional burial suggests something more than just the disposal of a body. It suggests ritual, it suggests grief, and it suggests the first, faint glimmerings of a spiritual or symbolic thought, a recognition that death was a profound and significant event. They were not just intelligent animals, they were a people, with a rich and complex culture of their own. While the Neanderthals were reigning in the cold north, a different story was unfolding on the continent where our journey began, Africa. In the vast and fluctuating savannas of their ancestral homeland, a new kind of human was emerging from the lineage of Homo heidelbergensis. This was us, anatomically modern Homo sapiens, the earliest fossils of our own species, from sites like Jebel Irhoud in Morocco, date back to around 300,000 years ago. These early humans had the high, rounded skull, the small, flat face, and the prominent chin that defines our own anatomy. But for a long time, their behavior remained much the same as their ancestors. Then, beginning around 100,000 years ago, something new and revolutionary began to appear in the African archaeological record. This was the dawn of behavioral modernity. We see the creation of new and more sophisticated stone tools, long, slender blades that were more efficient and versatile than anything that had come before. We see the first evidence of long-distance trade, with seashells being transported for hundreds of kilometers inland. And most importantly, we see the first undeniable evidence of art and symbolic thought. In caves like Blombos in South Africa, our ancestors began to engrave abstract, geometric patterns onto pieces of red ochre. They began to drill holes in small seashells, stringing them together to create the world's first jewelry, the first personal ornaments. This was not just a technological revolution, it was a cognitive one. It was the birth of the modern human mind, a mind that was not just concerned with the practicalities of survival, but was now capable of abstract thought, of creating and sharing symbols, and of building a complex cultural world. This new cognitive toolkit, likely facilitated by the full development of complex grammatical language, was our species' greatest weapon, the key to our eventual and total conquest of the planet. And around 60,000 years ago, armed with this new and powerful mind, our ancestors began their final and successful great migration out of Africa. They spread first into the Middle East, and then across Asia, and into Europe. And in Europe, for the first time in history, they came face to face with another, different kind of intelligent, tool-making, fire-wielding human. They met the Neanderthals. For perhaps 10,000 years, these two great human lineages, the children of the ice and the children of the sun, shared the continent of Europe. What was this encounter like? The evidence is sparse, but tantalizing. We know that they lived in the same landscapes, hunted the same animals, and sometimes even used the same caves, though perhaps at different times. But the most profound evidence of their interaction is written in our own DNA. Genetic analysis has revealed that all modern humans of non-African descent carry between 1 and 4% Neanderthal DNA in their genomes. This is undeniable proof that our ancestors and the Neanderthals met and that they interbred. We are, in a small but significant way, their living descendants. But this encounter also marks the beginning of the Neanderthals' end. Around 40,000 years ago, after a reign of nearly 500,000 years, they vanished from the fossil record. Why they disappeared, while we survived, is one of the greatest mysteries in human evolution. It was likely not a single, simple event, but a complex combination of factors. The climate of the last ice age was becoming even more unstable, and the more adaptable, technologically innovative Homo sapiens, with their wider social networks, may have been better equipped to handle the changes. Or perhaps our ancestors, with a higher birth rate and a more efficient way of life, simply outcompeted their cousins for the scarce resources of Ice Age Europe. Or, It may be that they were not so much extinguished as they were absorbed, their small populations slowly interbreeding with the larger incoming populations of modern humans until they faded into our own lineage. Whatever the cause, by 40,000 years ago, our species was now the last human on Earth. The world we now enter is the world of the last glacial maximum, the peak of the last great ice age, which occurred around 20,000 years ago. It is a world of almost unimaginable cold and ice. Colossal glaciers, kilometers thick, now cover the northern continents at their greatest extent. The Great Laurentide Ice Sheet smothers all of what is now Canada and stretches south to where New York City now stands. In Europe, the Scandinavian Ice Sheet covers all of northern Europe. The air is brutally cold, dry, and filled with a constant, scouring wind that picks up dust from the vast, barren plains left behind by the retreating glaciers. This is the world of the Mammoth Steppe, a cold, windswept, and treeless grassland that stretches from the shores of the Atlantic in France, all the way across Eurasia, and over the vast, exposed land bridge of Beringia into North America. It was in this incredibly challenging and unforgiving environment that our own ancestors, the modern humans who had recently arrived in Europe, did something that no creature on Earth had ever done before. They began to create art. This was not the simple, abstract scratching of their African ancestors. This was the beginning of a true artistic and symbolic explosion, a revolution of the mind. Deep within the limestone caves of what are now France and Spain, these Ice Age hunters, the people of the Upper Paleolithic, began to create some of the most beautiful, powerful, and mysterious art in the entire history of humanity. Let us imagine journeying with them. We leave the cold, bright, windswept world of the steppe and enter the absolute darkness and silence of a deep cave. With only the flickering, sputtering light of a lamp burning animal fat, we move deeper and deeper into the earth, through narrow passages and into great, vaulted chambers. And here, on the walls of these deep, sacred spaces, the world of the Ice Age is brought to life. Using charcoal from burned wood for their black lines and rich, ground-up mineral pigments, the red and yellow ochres for their colors, they painted a magnificent and vibrant menagerie of the great beasts they shared the world with. There are great, galloping herds of wild horses, powerful, shaggy-maned cave lions, woolly rhinos with their heads lowered as if to charge, and immense, majestic woolly mammoths, their curved tusks sweeping across the rock. The artists were masters of their craft. They used the natural, curving contours of the cave walls to give their paintings a stunning, three-dimensional quality, making the animals seem to bulge with muscle and life in the flickering lamplight. Why did they create this magnificent art in the deepest, most inaccessible parts of the caves, in places they did not live? We will never know for sure, but it was clearly not for simple decoration. Perhaps it was a form of hunting magic, an attempt to capture the spirit of the animals they needed to hunt to survive. Perhaps these were sacred spaces, the first great cathedrals of humanity, where shamans would journey deep into the earth to connect with the spirit world. Or perhaps it was simply for storytelling, a way to record the great myths and histories of their people, a visual library in the heart of the earth. And their creativity was not confined to the cave walls. They also created beautiful and intricate portable art. They carved exquisite, lifelike sculptures of animals from mammoth ivory and reindeer antler, and they sculpted the famous Venus figurines, small, stylized statues of female figures, which have been found from France to Siberia, a testament to a shared cultural and perhaps spiritual world that stretched across the entire continent. And we know they had music. From these same caves, archaeologists have found beautifully crafted flutes made from the hollow bones of vultures, instruments that when played today still produce clear, haunting, and beautiful notes. This was a world of art, of music, of ritual, and of profound symbolic thought. This was the true and final dawn of the human spirit. And armed with this new, creative, and cooperative mind, our ancestors now completed their conquest of the planet. Around 65,000 years ago, they had already accomplished one of the most remarkable feats of exploration in human history. Using simple rafts or canoes, They had crossed the open ocean to reach the continent of Australia, becoming the first humans to ever set foot on that new world. And now, at the height of the last glacial maximum, they embarked on their final, great migration. With so much of the world's water locked up in the great ice sheets, the sea level was low enough to expose a vast, cold and dry land bridge connecting Siberia and Alaska. This was Beringia. And sometime between 20 and 15,000 years ago, small groups of Ice Age hunters, following the great herds of mammoth, bison, and horses, walked across this land bridge and into the Americas. They were the first people to ever enter this new hemisphere. From there they spread south, through an ice-free corridor that opened between the great glaciers and into the heart of a continent that was filled with its own magnificent megafauna and was, for a time, a true hunter's paradise. Then, beginning around 14,000 years ago, the world began to change, rapidly and dramatically. The great orbital cycles shifted, and the planet began to warm. The ice ages came to a sudden and violent end. The colossal ice sheets, which had dominated the northern hemisphere for 100,000 years, began to melt at a catastrophic rate. The meltwater created colossal, continent-sized glacial lakes, which would periodically burst through their ice dams, unleashing biblical-scale floods that scoured the landscape. Sea levels rose by over 100 meters, drowning the coastal plains and severing the land bridges, turning Britain into an island and closing the door to the Americas behind its first peoples. The cold, dry mammoth steppe was replaced by the temperate, wet, and dense forests and prairies that we know today. And in the wake of this great global thaw, one final, great extinction event took place. This was the Quaternary extinction event, the great death of the megafauna across the globe. But most dramatically, in the Americas, the great beasts of the Ice Age vanished forever. The woolly mammoth and the woolly rhino disappeared from the plains of Eurasia and North America. The great shaggy cave bears and the fierce cave lions vanished from Europe. The iconic saber-toothed cat, Smilodon, the great ambush hunter, disappeared from the Americas. The colossal giant ground sloths, the tank-like Glyptodons, and the Native American horses and camels all went extinct. Why did they die? The debate continues to this day, but it was likely a devastating 1-2 punch. The first blow was the rapid and extreme climate change. The habitats that these great animals were perfectly adapted to, the cold, dry mammoth steppe, disappeared in the space of just a few thousand years, replaced by dense forests that they could not navigate or feed in. But the second blow may have been us. This great extinction event coincides perfectly with the arrival and spread of a new, incredibly intelligent and deadly predator into these ecosystems, Homo sapiens, armed with the sophisticated spear thrower, the atlatl, which allowed them to hunt from a safe distance, and working in large cooperative groups. Our ancestors were formidable hunters. The great megafauna, which had never before faced a predator with such a deadly combination of intelligence and technology, may have been hunted to extinction. And so, the Pleistocene epoch ends not with a bang, but with a great and final silence. The world, at the dawn of our own current epoch, the Holocene, 10,000 years ago, is a world that has been emptied once again. The great ice sheets are gone, and the magnificent megafauna, the mammoths, the saber-tooths, and the ground sloths are gone too. And on this new, warmer, and more stable planet, our own species, Homo sapiens, is now the undisputed and dominant large animal, the sole inheritor of a world that we had, perhaps, helped to empty. And with the great beasts gone, and the climate now stable and warm, our ancestors were on the verge of the single most important innovation in human history, an invention that would change our relationship with the planet forever: agriculture. This would set the stage for the Neolithic Revolution, the dawn of human civilization, and the beginning of recorded history.